Welcome everyone to this March community call. My name is Mark Fussell, and I'm one of the maintainers inside the Dapr repos. It's great to have you here today. Join us. On this call today, we have a very interesting agenda. We're going to have Manuel, who's going to start and talk about how he's used Dapr and CloudEvents to do integration between MassTransit and Rebus, and he's also showing how he's used that as an integration platform for CloudEvents in general. We'll then have Jeroen, who will touch on some of the features that are coming out of preview in the upcoming 1.7 release. In our next call in March, we'll talk a lot more about the 1.7 release and what's in it. I thought I'd do a little bit of a docs highlight. The docs, like the code, is always in constant transition, and we're doing improvements to them all. And I thought I'd just touch on at least one area where we sort of revamped the docs quite a bit. And then we'll have time at the end for some open discussion, which feel free to ask any question of your choice, whether it's a simple, how to use Dapr question, or up to, something about the in-depth API or proposal. So with that, I am going to switch over and let Manuel present, and he will take us away with Dapr and CloudEvents. Manuel.
You're muted.
I just unmuted, I think. Yes.
Yes, we can hear you now.
Let's move Zoom out of the desktops. Yeah, like Mark said, I will be talking about how I used CloudEvents as the central serialization format to gain interoperability between Dapr and MassTransit, and I'm still working on Rebus. On Rebus, there's a bit more work involved, but that's what we achieved at the customer last year. I'm Manuel Rebus. This is my GitHub handle. I have all sorts of nice repos and packages out there, so if you want to check them out, if you want to contribute, feel free. Hypothesis is one of the frameworks that I will be using today. It fits really nicely into asynchronous assertions. So like you have to do with an asynchronous model like PubSub, it really comes in handy when doing C#. This is my Twitter handle. I'm not out there much on Twitter, but if you try to reach me, then you will find me. What I will be showing today is how two services, both written with a different framework, so to say, can interop using the PubSub mechanism and exchange messages, because the key driver here is for sure CloudEvents. When both parties apply to the same standards, it's possible to exchange messages, and Dapr does that by default, so applause for that. And MassTransit needs a little help on that, and that's what I created, that's what I built, and I will show you in a minute how that is done, how that is used. If you have questions, if I'm not clear enough, don't hesitate to interrupt me. I will be happy to do that while discussing this topic. MassTransit is not a small one. On NuGet, it even has more downloads than Service Bus. It's an open source alternative. That's why I picked that one. But for sure, I really wanted to do Dapr, but I will come back to that in a minute. At our client last year, this is what we were faced with: a microservice landscape hosted in Kubernetes. But what it really was under the hoods was a distributed monolith. All services knew where all the services were, and they interacted directly. It was all REST-based, so Service A knew how to get data from Service C, and Service D knew how to get data from Service A and Service C. Service B was even a monolith in itself. It had two purposes, which was really obvious by it using two separate databases, storing different kinds of data that were not related to each other. So this was the legacy we got when joining there. And because it was so tightly coupled, you couldn't really Is that on my side? No. You couldn't really develop parts of the application without having all the other services there as well. So on your local machine, you had Docker running using Kubernetes, and in production, there was Azure Kubernetes services running where the same set of services were deployed. It was a mix of C# applications and some Golang applications. So this was the landscape we had to deal with. And what we wanted to do is we wanted to introduce a service bus in between to create decoupling so that you were able to host and run service A without the need for the other services to be in place. And yeah, as you may see from this picture, Dapr would be really a great fit because it supported all the requirements. You could use the C# SDK to publish your messages. It was already running in Kubernetes, so the sidecar was not a problem at all. There was already a Golang SDK, so you could even use that. But when we raised that opportunity, the ops came by and the ops said, no, we don't want Dapr in our cluster. We don't trust the architecture yet. We have to look very carefully into it, and we don't allow additional namespaces and hooks and all the kind of stuff that you need to have. So that was a bit of a drawback, a setback. We couldn't use Dapr at the time. But Dapr set us up to the path of CloudEvents. So to be truly interoperable, we knew that we had to use CloudEvents. So at first we created the homebrew framework that we used across the C# services, adopting CloudEvents from the start. And halfway through the project, I was able to create a MassTransit adapter that I proved to be compatible with that homebrew framework. And in the second phase, I even proved it to be interoperable with Dapr. So that's what I created, a MassTransit adapter that's out there on NuGet. It's out there open source. And I've developed it with Dapr as the driver of that adapter to prove that a message published by Dapr was correctly received by MassTransit. And I used Dapr as the stub that when I publish a message using MassTransit, it was correctly delivered to Dapr. So that's true interoperability between the two frameworks. So for now, they are using MassTransit with a CloudEvents adapter, but in the future and for the Golang applications, they can use Dapr straight away. So this is the demo I created for today. I've developed a service with Dapr. The service receives a post request from curl. The service publishes that event on RabbitMQ using Dapr, using a sidecar, and MassTransit is listening to that same broker, receiving a message and responding that it's delivered to Dapr again. So this is my first service, my Dapr hosted service. I've set it up as a ports and adapters architecture, or a hexagonal architecture, if you like. So the heart of this application is the handler. The handler receives a new request and tells the publisher to publish it. The handler receives an approved message and it updates the request in the store. And you can ask the handler to retrieve the request from the store to see the current status. Then I implemented the two adapters for the store, an in-memory store that, as the name says, just stores the requests in memory, and a publisher adapter that's a wrapper around the Dapr client. So the core application doesn't know anything about Dapr. It doesn't know anything about the bus. It only knows I have a port to publish events. I have a port to store the events, and these are the implementations. And in the end, the API ties it all together. So inside the API, all services are registered on the dependency injection container. I have my handlers defined here so that it's reachable on an API endpoint. And that's all there is. So I can now start this API. Oh, I'm sorry. I will start the self-hosted sidecar for now, just for demo purposes. And after that, then I do a curl request. It creates the request, it stores the request, and it returns an ID and the current status. Right now, I have to find my other tabs once more. Right now, you see the topics, the exchanges and the queues that are created by the sidecar based on the subscriptions as I lay them out in this handler. And then there is my service B, my MassTransit application that just is a MassTransit application. So if I run this application, it will create its own queues. It will create its own exchanges. And yet they are not working together at the moment. If I publish another request, it gets created, but it's not delivered to the MassTransit backend. In order to do that, I need two things. I need my own framework to tell MassTransit that it should use CloudEvents. And I need to bind the messages from MassTransit to a dedicated exchange instead of the default resolved exchange. I have to bind it to the exchange that Dapr is also using. And the other way around, when I publish a message, by setting the entity name, I tell MassTransit which topic it should be delivered to. So these three things need to be in place. You need to tell MassTransit it now needs to use CloudEvents, just like you do for Dapr. You need to tell MassTransit what the exchange is that you want to be listening on. And you need, for the outgoing messages, tell MassTransit what topic it should be delivered to. And now if I run this application, and I publish yet another message, and I try to query that. Where is it? Now you see that the status is updated. So there is a message that went from the Dapr created exchange to the MassTransit created queue, and from the MassTransit delivered a message back to the Dapr created exchange that was delivered to the Dapr created queue. Two things worth notice is that inside my integrations test for this Dapr service, I have used, like I said, hypothesis to create an awaitable hypothesis. I say here, I expect a message to be delivered with the ID 1234. And then when the message is delivered, I start testing my hypothesis. And as soon as that hypothesis is broken, or after the time is expired, my test will fail, stating that, yeah, your hypothesis is invalid. But as soon as the hypothesis is valid, then your test will also pass. So this is a nice framework to do asynchronous assertions. because you can just await the hypothesis for it to become valid or become invalid. And the second thing I created is I created a package to easily start and dispose sidecars. So this is to manage your sidecars from your integration test. And the last thing that is a contribution from mine to the Dapr concept components is the in-memory pub/sub. That is nice to use when doing integration tests like these, because then you don't need a real broker to be available. You don't need RabbitMQ, you don't need the Azure Service Bus. You can just deliver your message through the client to the sidecar, and the sidecar delivers it back to your application, to the REST endpoint that you're hosting. So these are the things that I managed to create during that journey at that client back then.
Manuel, one of the questions that's been asked from George is, what's the name of the hypothesis framework? I think you showed it at the beginning, yes? It's called
hypothesis.
It's called hypothesis, yes?
Yes. So I've created an adapter for MassTransit to be cloud event compliant, and it being cloud event compliant with some default configuration of the framework. It's very much possible to exchange messages with, for example, Dapr, where cloud event is the silver bullet for sure. I've created hypothesis for async assertions. I've created wrapper for the sidecar to start a self-hosted sidecar from your integration test and close it afterwards. And I contributed an in-memory pub/sub component for testing. And this demo I just gave you, where all these parts come back, is also published on GitHub. So that's just what I had to share with you.
That's super cool. Tell me, did you use the MassTransit in a? Have you used the MassTransit in a solution that's been deployed at the customer yet, or is that didn't happen?
I hope so. We left the company before it went to production. It was already developing for quite some time, but we didn't get to celebrate the production release.
Yeah, but I mean, the cool thing here though is that CloudEvents is a standard, which is part of CNCF. You know, you've, as you said here, you've cloud eventified MassTransit now, so that it becomes a standard pub/sub mechanism for sharing with other cloud eventified pub/sub services like Service Bus, for example, inside Azure, or and one that and anything else is integrated with Dapr itself. Yeah.
Yes. And that really lowers the barrier when picking and choosing your framework of the liking, because now you can make different choices for each service, because in the end they will be able to exchange messages, and that's the really cool part here.
That's super cool. Yes, and thank you for contributing the pub/sub in memory component. I think that's something that, from local testing perspective, that you can just pull up that and run that in memory, and without having to install any other, without having to install any other components themselves. So that must be pretty useful for yourself, yes?
Yes, exactly. And I can imagine that's also good for examples and docs, but on the other hand, maybe it may be disguiding that what the essence of pub/sub is. So for integration testing, it's really cool. If it's good to show how Dapr does pub/sub, I'm not so sure if it still comes in handy.
Yeah. Well, pretty good. Anyone have any questions for Manuel around these? A couple of people said fantastic. Thanks for the contribution. Phil says, I've used the in-memory components and it's pretty good.
Nice, great.
Yeah, the in-memory pub/sub component is really useful to help users who don't want to run things like Docker on their machine, just to have Redis as the pub/sub component. And another Dapr contributor actually followed up on that, and we have an outstanding PR for an in-memory state store component too.
Nice.
Based on what he saw with the pub/sub component. So I imagine there's going to be a few more in-memory components that make it a lot easier to just get started with Dapr without Docker. So that's really great. Thank you.
Yeah, cool. Nice to hear. Yeah.
All right. Well, thank you, Manuel. That's fantastic. If anyone wants to ask any more questions, Manuel, feel free to post them in the window and he can pick them up and take them from there. But this was fantastic. So thank you for sharing.
Yeah, you're welcome. Thank you for having me here.
Yes. All right. Let me just share back on my screen here a moment. So next up, we're going to talk about the upcoming 1.7 preview, at least how we're going to remove some of the features inside this. And I'm going to let Jeroen take over. So Jeroen.
Yeah, I'm sharing my screen. Let me know when you can see it.
Looks good.
Looks good. All right, cool. Let me just minimize the Zoom window here. All right, so currently the following features are going to be removed from being preview features in the 1.7 release. So the first feature that we're talking about is gRPC proxying. And gRPC proxying basically allows users to use their own protobuf definitions, their messages and services with Dapr today. Up until gRPC proxying, for users to be able to leverage gRPC with Dapr, they would need to call a dedicated gRPC method on the Dapr API, and they could not use their own proto services. And also the apps that were acting as the consumers of the call would basically need to implement a gRPC service that was supplied to them by Dapr. And that basically undermined pretty much 95% of the benefits of using gRPC, because you simply couldn't use any of the gRPC building blocks, and you had to use Dapr methods and services to be able to use gRPC, which was not an optimal user experience for sure. And so with gRPC proxying, you use gRPC as the project means you to do. You use your own packages with your own proto services, your own proto messages, and instead of hard coding the call to a well-known address of the target service, you simply call your Dapr sidecar, and then Dapr does the rest and puts in telemetry in place and mutual authentication, retries, and all that jazz between the calls. So that feature is now coming out of preview, which means that you won't need to explicitly turn on in configuration. I'm going to show you how it's done today to enable features, preview features in Dapr, but you're not going to need to do that anymore. The next feature that we're taking out of preview is state encryption. So today, when an app calls Dapr and Dapr saves state, that state is not encrypted. We came out with Dapr state encryption a few releases ago, where a user can basically supply their own encryption key based on AES 256 bits. And then Dapr would essentially take the state that's executed, that is being given to it, encrypt it with the encryption key, and then store it encrypted in the database. And once you're getting back the state, Dapr would use the decryption, and it also supports key rotations. So that's another feature that we are planning to take out of preview. Third feature is actor reentrancy. Actors are a specialized programming model that's exposed by Dapr. And I'm not going to go into what actors are right now, but just to explain, in a very high level, think about being able to model things like IoT devices or logical devices in the world, like rooms or windows, as actors. And each one of these can contain their own business logic and state, and Dapr will distribute these units of compute and state throughout the cluster. If any of them fail over, Dapr will make sure that they either fail over to the same machine or even cross machines and hydrate the state if it had the state, if it has a state associated with it. So, for example, one of the good program model features that actors have is single-threadedness. So you can have any number of rooms, but every operation that you invoke on a room, let's say closed door or open door, is single-threaded. So if you have 3 requests coming in, the room actor will wait until the first operation is done before it is able to serve the second request. And so this is pretty good because developers do not have to think about concurrency or multi-threading in their application. They know that their actor is single-threaded, and you basically scale out using different IDs for rooms. So you might have several complex scenarios there where a room actor actually wants to call a window actor, and that's perfectly valid. So let's say someone wants to open a window in the room, so they call into the room actor, then the room actor calls the window actor to perform an open operation, but for whatever reason, the window actor needs to reach back into the room actor to either get an information about the other windows or signal something to the room. Without actor reentrancy, that would cause a deadlock because the window actor would basically wait on the room actor to wait for it to finish its job. So with actor reentrancy, that scenario is now allowed. And if you're calling an actor of type room, which calls window, and then window calls room again, the room actor will know that the window actor is actually part of the call flow, and it would actually allow the window actor to reach back into the room actor and complete the operation while the room actor still adheres to the single threadedness and sequential flow of operations from other recipients who are not the window actor. So this form of reentrancy allows for parallel operations in these types of scenarios. And that's the last feature that we're taking out of preview. I'll be taking questions now. And I'm going to stop sharing. Any questions? Okay, that's all.
Does CloudEvents play a role in the gRPC? I'm not sure. What would there be a place for it?
So CloudEvents plays a part in Dapr pub sub, not for proxying. So for proxying, users would have their own proto messages. Well, they could send CloudEvents, right? They could decide that one of the fields that they're sending on their message is a cloud event, for example. But Dapr in that particular building block will not do anything special with a cloud event. It'll just pass it through as is. Or Dapr pub sub actually does many things and really is, like you said in your talk, geared around pub sub and its extension mechanisms to look at things like TTL and other features.
You're on proxying is really solving problems with doing servicification in making it better for kind of your existing code. Is that the way to think about it?
Yeah, existing code, and well, it works really great for both greenfield and brownfield, right? Even if you're starting to develop your application now, you don't want to do it using the old way. We're gonna probably deprecate the invoke method type of operation that we currently have on the SDKs, and we really have been trying to encourage users to go to HTTP clients and just native gRPC clients as far as service invocation is concerned for a few months now, actually.
Right, and then the service looks more like the RESTful HTTP or gRPC service shape you had in mind anyway, right? At that point.
Correct. Yeah.
Okay, any other questions for Jeroen about those preview features? If you weren't fully aware, preview features get turned on through configuration. I don't think.
Oh yeah, I didn't actually show that.
Yeah,
that's something that I forgot to show.
You want to show that just to kind of show effectively what it's like, because sometimes it's not so obvious because each time we actually turn on preview features. So many features come in as preview first.
Yep, you can see on screen, I suppose.
Yes.
Yeah, so if you're familiar with the concept of a Dapr configuration, it's this file that lets you tweak things and turn features on and off for a Dapr application. This is an example of a configuration. So this section here governs tracing, for example. So we're configuring Zipkin for Dapr. And here's how you basically configure features for preview. So each preview feature would basically be inserted here under the feature section, where the name of the feature, for example, if it were gRPC proxying, feature one would be proxy.gRPC or something similar, and you would have enabled true or false. And basically by explicitly saying that the feature is enabled and set to true, you're allowing the Dapr runtime to enable it. And that's how you basically enable preview features.
Excellent. All right. Okay. So let's carry on. Let me share my screen here again now. So let's move on to the next topic. And I thought I'd highlight some changes we have inside docs. Our docs are continuously changing. So I'm sure you're super familiar with our docs inside here. We do lots of doc contributions that we have from the community. Many of them update, for example, component metadata specifications, and they're hugely sought after because they make sure that we get all docs current with the code base and things like this. One thing that we've recently just updated was if you go into concepts here, you see that we cover a lot of the concepts across Dapr itself in terms of talking about what configuration is and how it works and observability. And one area we revamped recently was just the whole security topic. Dapr has many security features built into it all, and sometimes it gets a little confusing about where they all are, and they get spread around, and there's plenty of information about how to use them all. But we decided just to pull these all together a little bit more into the overview. And effectively, if I just run through this, Dapr actually has sort of 4 main areas about where its security is focused. One is about its secure communication. Another one is about how it uses policies on a variety of different things like components, or on policies you can set in terms of how you receive pub subtopics. General operational practices about how you use Dapr in an operational world. And then specifically in one Jeroen just touched on there was encryption at rest, or having state security around these things. So this topic now in security concepts is sort of just try to pull this all together to give you the broad overview around it all. So for example, in secure communication, not only do you have the MTLS encryption between your 2 Dapr sidecars that are running to provide end-to-end security, but making sure that you understand that also there's API token authentication using JWT tokens that you can do between your actual application itself and talking to Dapr in terms of its APIs. So there's authentication here between that you can turn on between your application and Dapr itself. There's MTLS encryption on the wire between the two, so you can provide this full end-to-end security between your 2 services. But also, highlighting inside here is you can apply policies to these as well. So for example, service B can have policies applied that allow calls from particular services, like it can allow calls only from service A. It can allow particular endpoints on it to be called as well, in terms of it can allow only service A to call a particular endpoint on it as well. So you have these service endpoint access policies, and you can do the same with pub sub as well. So when you send messages over CloudEvents, you can actually set the access policies for whether a particular application can publish an event from service A to service B over CloudEvents, and deny and authorize particular topics inside them all. So this secure communication topic here just goes into the scoping of how you can scope the pub subtopics, the service invocation scoping to the endpoints inside here. And then a lot of this sort of deals with how you set up MTLS and some background around it all, how MTLS is set up in self-hosted environment, how it's set up in a Kubernetes environment, just as a background here. From an end user perspective, of course, you can just turn on MTLS. But this just provides you a background kind of information about how it works. The token authentication to the application itself is covered here. We then talk about how Dapr actually talks securely itself to the control plane. So you make sure that has security between your instance of Dapr running itself and the control plane. So that's nothing's here on why, because inside the control plane, you actually have an identity service here. Actually, you have a Sentry service that provides both identity to the application itself, plus issues certificates that get used by the Dapr sidecar for your application. So this talks about just how you have security on the control plane, but also importantly, this Sentry service provides a lot of the security capabilities around it all. Going on to the topic of operational security, in our last community call, Bernd covers quite a lot about certificate deployment and rotation and how you do this. There's an area around how you can do using typical types of OAuth providers inside middleware and setting those up. For example, providing OpenConnect or OAuth in terms of a middleware provider for authorization on your endpoints. And in general, you're thinking about your network security as a whole. Then going into the topics around security policies, you have actually API security policies. This may not be known to many people, but you can actually say from my sidecar, I only want you to be able to use particular APIs. So you can say, I only want my application to be able to call the pub sub API and bindings API and service invocation, but I'm denying the usage to the state management API and any other APIs such as configuration down here. So you actually have control over the API access policies themselves for a particular API that you're using. And then of course, within the service invocation itself, you have the previously talked about ACLing policy there for who can call your endpoint, your methods on your application over service invocation. You can actually scope applications to your scope particular components to your application. So you can say, I can only call and use components A and B from my application. And then generally bindings have their own security built into them all. Then you get into state security. As Jeroen talks about inside one of the preview features today, we actually have the ability inside Dapr to turn on security for at rest, so that when you store state into one of the approved Dapr state stores, you can actually encrypt that at rest. And then finally, and just there's a little note here, just as because this is a question that often comes up. Dapr itself doesn't actually store any state. It doesn't actually have sort of a backing database that stores any data inside it all. So one of the key considerations inside here is that it's effectively stateless in terms of how it runs as a runtime, so that there isn't any dependency on state stores itself. And then putting this all together, this kind of a useful example here that just tries to describe a way that you could use all of these different security capabilities. So for example, in this application here, which consists of an ingress that's been Daprized, that has Dapr running as a sidecar next to it all. It has service A and service B that are using Dapr for their communication. I can have a request that comes in to my ingress controller, say Nginx, and then it uses the API token authentication to make sure it's talking to its Dapr sidecar securely and not routing it to anywhere else. Dapr can then route messages securely and send them over to service A, and service A can sort of set access policies inside here to say the only service that can actually call me is this Nginx service and no one else. So it can restrict how it gets called. So this is the only way that it can call from external messages coming in, and sending that over a secure channel. And then service A can publish messages to service B, and service B over CloudEvents here. And so service B here can say, well, I can only receive topics from service A and these particular types of topics. And then in turn, service B here can actually restrict not only the components that it has access to through a component scope policy to say I can only access these particular components, in this case, a Redis state store. And then the Redis state store itself can sort of take advantage of encrypting its state that it uses inside there. Service B here limited itself to be able to say it can only access the secrets API, the state management API, and the pub sub API. And so it denied access to anything else. And then you can actually set another policy inside here to say which secrets you can access. So you can say that service B here can only access secrets A and B from the secret store and can't access anything else. So in this particular case, service B is only accessing the secret that it is allowed to in order to be able to do a secure communication in order to the Redis component that it has access to. And then finally, inside this example here, this is running inside Kubernetes. Each one of these applications runs inside their own namespace. So the namespacing provides secure boundaries between where your pods are running inside this Kubernetes environment, and it makes it another level of security around all of these. And amongst all of these applications, of course, get allocated MTLS certificates and identity from the Sentry service that's running as part of the Dapr control plane. So this is an example sort of just pulling it all together. It shows that there are many, many security capabilities built across Dapr, and you can really lock down Dapr and how it gets used in your applications to what you really perceive as the security boundaries that you have. This example here just walks through some of the text that I was just talking about. And then finally, just to send up here, we end up with just a threat model for Dapr itself that's always been here. and just pointing to security audits. So I just wanted to run through that because it kind of gives you an overview effectively of sort of the comprehensive security that we have inside Dapr, and how you can actually sort of put it all together yourself and just see all the different types of capabilities that are possible, especially through this example at the end here. So with that, I'll stop sharing and see if there are any other questions that come from people based on that docs update.
Yes, Mark, looks very good. The pictures also are very clear. One thing that may be under-explained in the docs is what the control plane is exactly and what's inside it. Because at that customer I was talking about, they were not willing to accept Dapr because of the control plane. They were worried that it would increase the attack surface of the cluster. So maybe that's something that is still missing in the docs.
Oh, okay, yeah, that's a good question. So the question is, well, they were worried about the attack surface of the control plane, and how secure it was in terms of having, because we have there, so the docs do cover how, if you go back to the docs do cover how the application to control plane security is locked down. But the actual control plane itself, was that concern?
Yes.
Okay, good feedback. Okay, any other questions? That's great. So let's at this time now move just to an open discussion. So at this point, feel free to post any questions you have in the chat window. Feel free to open up your mic. It's really a time for anyone to be able to ask any question, whether it's a particular issue that you have, whether it's a question about how you're using Dapr, whether it's about a particular proposal. And really it's your time to kind of have any particular feedback. So are there any questions? Oh, okay. So one question Paul posted was, is there any connection we make with, in the security context, to OPA policies? I don't know if there's the open policy was donated by a community person about a year ago, and really it's OPA is a standard in itself. I do believe it's part of CNCF. I'm not too sure if I'm correct in saying that. Am I correct in saying that, Jeroen?
Yes.
And so that just got implemented as part of middleware components. The good thing about it all is that you can apply the OPA policies as part of the middleware call that comes in. So the middleware allows you to parse the messages that come in over HTTP pipeline and apply OPA policies to them all. So if you're wanting to take advantage of OPA as a policy agent, as a policy, that's the way it got integrated into Dapr.
Thanks, Mark.
Manuel, do you have a question? Do you want to talk about your question, Manuel?
We already discussed it in the sync call we had last Friday, but I just wanted to point it out. Yes, for sure, I'm really fond of the CloudEvents spec. And right now, when you publish data using the official .NET SDK, then the only option you have is to publish raw data, and the sidecar will wrap it into a cloud event. Whereas the API already has the ability to detect that you publish a cloud event, and it just uses that to publish it on the chosen pub sub. Because right now, when using the official SDK, the sidecar has to make assumptions, has to fill in the required fields with dummy data, and so half of the cloud event spec, the value of the cloud event spec, is lost in that process. For sure, you can post it yourself just using REST API. That will work, but it would be nice if the official SDKs would also support that you tell the client the value for the different fields. For example, what is the type that you published?
Yes. Yeah, that's certainly something that should be available inside the SDKs.
Yeah.
Okay. Well, with that, then,
Wait.
was there another question?
Sorry, I just have a quick question about the pub sub as well. I'm working on a project right now where I'm creating some servers that want to receive a certain number of messages and then stop receiving messages and stop processing further messages. And I've been kind of looking into some of the settings in Dapr that allow you to configure that sort of thing. And I've had some success with at-max concurrency, which obviously controls how many messages are processed at once. But I have not been able to find any settings that allow you to restrict the number of active messages that are actually received and sort of kept in the backlog for a particular pub sub server that's receiving pub sub messages from the sidecar. And I guess my question is there a feature in Dapr to kind of block a subscription from receiving further messages, or terminate it, but in a way that allows existing messages to finish processing if there's a long job that is started by a message?
I think currently some implementations do support that. I think RabbitMQ supports that with a fetch count parameter that you can set on the component, but Dapr does not have a generic feature to implement that for all supported implementations. If you would want to see that, please open an issue because it sounds like a great feature to have.
All right, thank you.
Yeah, that's a good question, actually. And Phil replies, that sounds like it could be a bulkhead feature which could be added to resiliency. Yes, that's something that we'll probably spend some more time on in the next call. Is that Phil presented this a while back, was a resiliency policies, and they're coming out in a 1.7 release, and we'll spend some more time talking about those. But that is one place that could reside if we wanted to think about that sort of capability. Okay, good question. Any other questions that people would like to talk about or post in the window? All right, so with that then, I will close this call. Thank you for spending some time with us again this month. As always, this good choice to be posted on our YouTube channel, and feel free to follow up with any questions inside our Discord server.
Thank you.
All right, thank you.
Thank you.
See you.
Thanks, everyone.